The last data table we're going to look at is a two-way data table. And this basically allows you to change two variables at the same time and see how our outcome variable changes. Now right away you can see that I've set this up differently. Now we're going to have variables both in the column and also in the row. Because we have both a column and a row, the only place for our answer to go, right, the answer that's going to get copied into all of our data table, is in this top left corner. So with a two-way data table, we have inputs in the column and the row, and our answer in that top left corner of the data table. So the setup is very particular. If we don't set it up this way, Excel's not going to know how to build the data table. So we really have to be careful about how we set it up. So now if I select the entire range now, with inputs going both directions, again, I can go into my what if data table. And in the menu now, I have to pay attention to what's in the row and what's in the column. So in my row are my interest rates. So the row input cell must point to my interest rates. That's where I want the 2, 3, 4, 5, and 6% to go. The column input cell now is what's in the column. In this case, I'm doing the initial deposit is what I'm varying. So let's go ahead and put the initial deposit there and say OK. Obviously, again, we see that we get all the same value over and over and over again. If you see this, it's because the data table hasn't calculated yet. So I'm going to hit F9. That's to calculate now. And now all my calculations update. And now let's see what we can take away from this data table. We see in this first column that you basically have to save $45,000 a year if interest rates are only 2%. Now your initial deposit ranging from $2,000 to $8,000, right? That's not a lot of money, barely changes how much we need to save every year. So we see that a small change in our initial deposit doesn't really affect our total savings, whereas interest rates have a huge effect, right? 1% higher interest rate means we have to save $15,000 less per year, and then $9,000 less, and then $7,000 less, and then about $5,000 less, right? So going from 2% return per year to 6% return per year is a big improvement in how much we have to save. We have to save much less if we get very good returns on our investments. Okay, so that's the basic structure of the data table. Now, what if we want to change something up a little bit? You know, it was kind of silly to say, let's vary our initial deposit amount so little. So maybe we want to say, instead, let's start with 0, 10,000, and let's go up by $10,000 increments. So we'll do the previous cell plus 10,000. Paste those formulas down. And now we have a bit bigger dispersion. Now that I've updated those input parameters, all I have to do is recalculate my data table. And now we can see a little bit more spread in our results. Right? If I start with $0, I need $45,000 of savings per year. If I start with $60,000 in my initial retirement savings, now I can save $43,000 a year. So I get a little bit of benefit from that $60,000 I've already set aside, but I'm still really having to save a lot every year. You can see that same pattern as we go down to, say, 4%. You certainly benefit by having more saved, right? 21,000 down to 18,000, but it's not a huge difference as is caused by the interest rates. All right, so the last thing we might want to change is say, let's maybe don't do additional deposits. Let's scrap this data table. We're going to delete that. Let's change our inputs. Instead, let's think about retirement spending. So we looked at this a little bit before, but let's say, let's start with $50,000 of retirement spending. And let's increase that by $20,000. And we're going to vary that down the line. And we're just going to rebuild our data table from there. The reason we have to rebuild the data table is because this amount of retirement spend per year, it goes to a different cell. That points to C10, whereas our initial bonus was pointing up here to C4. So let's also change our header a little bit so it's no longer initial deposit. Now we're going to say retirement spending. So we're going to update our label. Now we're going to select our entire table. Again, the input cells across the top are for the row input. Down in the column are the column input. And then our output cell, what we want to record, is in this top left corner. Go back into our data table. Again, the row, it's going to go to our interest rate. The column now changes and goes to our retirement spending. We click OK, F9 to update, and now we see the results that we were looking for. Right? And interestingly, if we want to retire on $170,000 per year, well, if interest rates are 6%, we only need $15,000 saved per year. On the other hand, if rates turn out to be very poor, right, even if we save $15,000, $16,000 a year, we're not going to have even $50,000 a year in retirement to spend. So this gives us an idea of how important both our retirement savings goal is, as well as the interest rates or the returns that we experience over the retirement horizon. And importantly, the data table is what allows us to see this very quickly and efficiently. Right? We could have done this by just changing the parameters of our model and doing a lot of copying and pasting. That takes a lot of time. Alternatively, you could copy your model 30 times and create and vary parameters that way. Again, that's a lot more work than using a data table, which is a very elegant solution to testing lots of different scenarios for your inputs and understanding how they affect your model.